OSI model has 7 layers starting from application, presentation, session, transport, network, data link, and physical layers. Data is generated at the application layer on the client side. Data travels down the stack to presentation, session, transport, network, data link, and then physical. It is then transmitted through the network media. Data arrives at the physical layer on the server side, then moves up. When the server responds, server data goes down from the top layer application to presentation, all the way to the physical layer, and is transmitted through the network media to the client side. Then the data moves from the physical layer, data link layer, all the way to the top layer application, thus completing one round trip. The round trip of how data flows through all these 7 layers on both sides is a physical path on which data actually flows. Keep in mind, the OSI model also addresses another important aspect: how data flows on a logical path, layer-to-layer communication. For example, the sender's application layer generates data, while the receiver's application layer reads data. The presentation layer encrypts and compresses the data, while the receiver's presentation layer decrypts and decompresses data. The transport layer chops up data into segments, while the receiver's transport layer puts all these segments together. The sender's network layer makes packets, while the receiver's network layer opens the packets. At the sender's data link layer, frames are created, while the receiver's data link layer opens frames. Now, let me talk about the OSI model layer by layer. Let me start with layer 7, application. In non-technical terms, the application layer is about user applications, such as Firefox, Chrome, or Safari for websites, or Microsoft Outlook for email. Technically, this application layer refers to application protocols such as HTTP for web pages, and SMTP, POP3, and IMAP4 for email. These protocols facilitate communication between your application and your operating system. Application data is generated here. Layer 6, presentation layer. The presentation layer provides a variety of coding and conversion functions on application data. These functions ensure that information sent from the application layer of the client would be understandable and comprehensible by the application layer of the server. To put it simply, this layer tries to translate application data into a certain format that every different system can understand. For example, if I send a picture to my friend's computer, I must use standard formats like GIF or PNG so that my friend's computer can understand. If I want to share videos on YouTube, I must use a standard format like MP4 or AVI. Therefore, the main functions of this layer are data conversion, data encryption, and data compression. Layer 5, session layer. The best example to explain this layer is a telephone call, in which first you establish the connection, then start a conversation, and then terminate the session. Thus, the major function of this layer is to establish, manage, and terminate connections between the sender and the receiver. Without this layer, the data would not go any further. Layer 4, transport layer. The transport layer accepts data from the session layer and chops the data into smaller segments, and adds header information such as destination port number, source port number, and sequence number, which is used by the receiver to put the segments back in order and assemble them. The main protocols in this layer are TCP and UDP. Here we only need to know that TCP is the dominant protocol. When the transport layer completes its job, these segments move to layer 3. Layer 3, network layer. The Internet Protocol, or IP, the primary protocol at the network layer, takes the segments and adds header information such as sender's IP address and receiver's IP address. Thus, packets are created. The network layer is all about IP addressing and IP routing. Without this layer, packets will never travel to other networks. The receiver's IP address is like a mailing address on an envelope. Without it, your letter will never be delivered. Layer 2, data link layer. When the IP packets arrive at this layer, more header information such as source and destination MAC addresses is added to each packet. FCS is also attached to the end of the packet. Altogether, Ethernet frames are created. MAC address is the physical address for your network interface card, or NIC. The NIC has a crucial job of creating frames on the sender side and reading or destroying frames on the receiver side. Last but not least, Layer 1, physical layer. The physical layer accepts frames from the data link layer and generates bits. These bits are made of electrical impulses or light, depending on whether copper wires or fiber optics are used. Through the network media, the data travels to the receiver, thus completing the whole journey.